Welcome, everybody. My name is Shikha. I work at IBM, and we are really looking at setting up the cloud provider for enterprise customers, and that's Erica. You want to introduce yourself? Introduce yourself?
Yeah, I'm Erica. I also work for IBM, lead software engineer with Shikha.
Thanks. So what we are going to talk about today is getting to a production environment and what it takes to get there. We have seen a lot of talks on creating containers, setting up Kubernetes, but what we too decided to work on was to figure out what are the key capabilities are needed both in the during the time of container creation and during the time of setting up the Kubernetes to really help your application be production grade. So when you think about the production, what things comes to your mind? Security, resiliency, high availability, 24/7, repeated deployments, updates that needs to be done without any downtime. So those are the things, and the last not but the least, agility. So now it's not like your application is running for 6 months, a year before you get the updates. It's like weekly updates are needed too. So that's what comes to mind when you think about the production application. And except the younger folks, I'm sure some of us can relate to this slide, which is when which is when you have a production environment and a failover environment. So if those goes down, then there's something to back up. This is the copies of your application running on systems. And the painful part was to make sure that the data and the transactions are all replicated across. So I have lived through this. That's where when the Kubernetes came out, it's so much more relaxing and more fun and really easy to manage. So going to the next slide. As a developer, we would really appreciate if we were just left to do our coding and really get to this model right here. I can design, develop, test, and release. And not release per OS or not release per staging, dev, or production environment. So just release and be agile. So agility is added now, which could be weeks, maybe months sometimes, but it's usually weeks. That's what we think of when we come to agile coding. So build, ship, and run anywhere. And that's what the containers promise us. Then the next one is, for me, it's really helpful if I can offload the deployment, HA, resiliency, upgrade strategy to somebody else and not worry about it. That's another dream, and that's where containers, Kubernetes, and Cloud Sail comes to mind for production use case. So what does it really mean for my applications? The applications now, if they're not monoliths anymore, I'm learning to use this. Okay. They're not monoliths anymore. They need to be broken down microservices. And that's a good thing because I might be just good at the UI development. Or I might be just good at back-end development, just doing the transactions. That's where breaking down into microservices is a really good thing. And that's where containers come in. You can break the microservices down and follow the continuous delivery and continuous integration model. But with that, some challenges comes as well, because you need to make sure your containers are running together well, and so. Then you need to offload your management of the containers to somebody else, and that's where Kubernetes comes into play, and that's why we are all here. Last but not the least, the security comes in at each step. It doesn't come in at the very end. It comes right from the beginning when you're building the container, when you're writing your application, your microservice, to installing it in the production environment or running in Kubernetes. And that's the bottom line there. Now the rest of the slides, what we thought of was to go through what are the key best practices we found while creating these containers for shipping our product, plus what does it mean when you're running in the Kubernetes environment, and where did we land up. So those are the things that we're going to cover. For building containers, this is a key one. We have seen this happen inside our place as well, where you would go download an image from the Docker Hub and use that to start building your application. That's a no-no. It should be small image, and then to be best, there should be a private trusted repo for the organization where you can run security checks and all. That's a must-have for the production setup. Remove any vulnerabilities. So not only at the time of when you take the base image or when you create your image, but repeatedly as you ship. Ouch, sorry, go back. One more, okay. Sensitive data, no passwords in your Docker files. Should be self-contained. Now we say that, but as a developer we know that's not always possible, but it should be mostly self-contained. One thing to keep in mind is that downward dependencies, no hard dependencies on the downward APIs. It should be very self-contained. Degrade gracefully is the key. Immutable. You should have the same image for all your environment. As I say that, I know there are some places where it's compromised. It's not same container image in your production dev, but that's the key here, to make your container image immutable. And single process per container. I think we're all agreed to that one. The other one is what's running, how you're creating, how you're coding your image to create the containers. Non-root. Run your containers as non-root. We have Docker files to show at the end as well. But anytime a user gets access to your container and your container is running as root, pretty much that user has access to the host system. And that's a no-no for production environment. No ownership of this supporting subsystem like storage, your database, Mongo, etc. No direct dependencies. You should have, what we'll go through later is liveliness probes and readiness probes. You should never have direct dependencies and wait for the system to come up. Configurations in the config map, and secrets and sensitive info in the secrets. That's a really good thing that we get from the Kubernetes, where you can use those variables. Long-lasting data, as we know that containers are transient. They'll go up and come down, and we might have done some of these mistakes earlier, but all the long-lasting data should be in a database. Run with minimal privileges. There is a concept in Kubernetes called PSPs, Pod Security Policies. We actually enabled that in IBM Cloud Private, and we'll take you through the demo a little bit, where you can define very minimal privileges, only what's needed for your pod. For example, if you just need the access to the host files, you can specify that. There are at least 12 or 14 different access that you can restrict using the PSP. Disposable. Yep, let the containers die. Kubernetes will bring it up. When it brings it up again, make sure that it runs. It can run properly. And log to standard error, standard out. Okay, this is more or less a repeat of my first slide, where once you have the containers, how do you run for the production environment? Those are the same things that don't go away when you talk about the production environment. Resiliency, HA, scaling out and shrinking back in, security, upgrade, rollback strategy, monitoring, logging, and metering, the observability that's needed for the system, because when the tickets come in, you do need all of these set up. storage management, and there's definitely a lot more. And that's where KubeCon or Kubernetes comes in, where we have Kubernetes provide us the controls that we need to make sure that our applications are running with the production grade quality that we need. So I won't go through the slide in detail. We talked about it, and we know what Kubernetes provides. People are familiar with Kubernetes here, like basic concepts, all good. People know, everybody knows here pod, because we'll be referring to these in the following charts. Everybody knows. Okay, thank you. Thanks for the response. Okay, going to the scaling first. That's the, I need to learn the clicker here first. Okay. What we did in our demo sample is to create the deployments, and there's a reason here. The deployments really manages the replicas, and replicas are great for having your high availability concept in place, and replicas actually helps manage something that I have in the next slide, rolling updates. Those are really important ones to keep in mind when you're setting up your Kubernetes and you're running your pods or configuring your pods. Deployments instructs the clusters how to create and scale apps. So here is the deployment. You can see deployment manages the replica sets, and replica set has the templates, how to create your containers, and also tells Kubernetes how many to run at a time. So you can have 2, and during the time it's running, when your production environment is up, you can change the number of replica sets. You can change the number of replica sets. That's really great once you figure out if you need more of your containers running. And then in addition to, and this is a service, I didn't go through the basics, but this is your service that actually is talking to these two pods together. Auto-scaling, that's the new concept that came out. There has been several talks yesterday on it. There is really 2 HPA, horizontal pod auto-scaling, and the other one is vertical pods auto-scaling. HPA is GA, and it's really great to use. It just works on the CPU usage, so you can define the resource metric, you can define the usage. As of now, Kubernetes supports CPU. Based on CPU usage, you can put the HPA policy in place to drive how many replica sets to be added, which is really good. And there is VPA as well, vertical pod autoscaler, which works vertically. It's still in beta, it's not GA. And there is also cluster autoscaler. I have not gone and looked at this, but I heard CA is GA as well, so might be good to look at. But back to the HPA, it does provide you a way to plug in custom metrics. So you may not be interested in CPU only. You might be looking at load or how many transactions are coming in. Based on that, you want to increase your replica sets. That's possible as well. This is a very neat thing with Kubernetes. You can enable your updates. You can come up with your upgrade strategy when you are ready to create your deployment sets. Here, deployments allows for rolling out updates for cases where really backwards compatibility is there. There are always some security updates needed. That's where this comes out very handy. Right here is the snippet. So minimum ready seconds, it is the time your application boots up. So by default, Kubernetes will think that your application is ready as soon as pod comes up. But with this, you tell the Kubernetes that how much time it takes for your app to come up, and it'll wait for this many seconds. Maximum search is the number of pods in addition to the desired ones. So if you want during your rolling upgrade, you want an additional pod to be up and running before the pod goes down, you may want to send this up. And maximum unavailable pods is the number of pods that can be unavailable at the time it's doing the rolling upgrades. By default, I need to go look, but I think by default this is 1. It's a good idea to set it as 0 so that, you know, once all your updates are done and your new pods are ready, only then Kubernetes takes down your older pods. Okay. Application stability. That's where these two health checks comes in, the 2 pods, liveliness probe and the readiness probe. I have an example of liveliness probe here, but the readiness probe is similar. Liveliness probe indicates when the application is ready and running. Readiness probe tells Kubernetes when the application is ready to take traffic. So if you're lazy and if you're planning to implement one of these 2, make sure you do the readiness probe for sure. Because this tells when your application is ready to take traffic, otherwise your traffic will go nowhere. There are really 3 types. HTTP1 is the example here. And then you can also add command or TCP. Requests and limit and resource quota. I was at the talk yesterday, and it's really great to see when similar concepts are getting talked in other talks. That really means that when 2 people or 3 people are sitting and creating the chart, they're thinking of the same thing. That tells you that, you know, these are important and, yes, valid points and good thinking there. So I saw a similar discussion yesterday in one of the talks. It was from an Elasticsearch. I'm embarrassed I don't remember the name of the person, but he was talking about similar production environment. And we talk later about this as well, where we definitely need to make sure that our containers are running with the requests and the limit setup. Request tells the customer, request guarantees that Kubernetes will definitely provide the memory and CPU that you asked for. Limit tells you that this is the one that it can go further add for you. So that's a really good thing to do. And I'll tell you why. If you're running your containers and somebody else starts adding more containers, and if you haven't specified this, you might be really fighting for the resources for the containers that have been running so good and your applications are up and running fine, and all of a sudden you figure out that your applications are not doing good. So it's a really good idea to set this up. Resource quota. When you're setting up your Kubernetes, you can organize Kubernetes into namespaces. And resource quota really helps. It provides a constraint towards aggregate resource consumption per namespace. So if you can think about if you're setting up your cluster, maybe with a dev namespace and a production namespace, it's a good idea to limit the dev namespace with a certain number of compute resource. So right here is the example of resource quota. You can specify, I see a typo here for myself, request.memory and request.cpu this is the value specified there, and it really tells Kubernetes the maximum combined CPU request or the compute request in the unit for all containers in the namespace. So it really sets the quota up. I'll touch on one more point here. When you're setting up in your environment, when you are the cloud provider, you want to charge your departments that is using your cloud. And that's where this comes really handy, because you're setting this environment up, you know exactly how they're exactly what they're using, and that's how you can make sure you can charge them well, accurately. So now a little bit about security. As we went through setting up the environment, these are the important things that we had to make sure that we are definitely doing. No components talks to each other without certs. There should be certs enabled. And it should be through secrets. You cannot, it's not a well-known cert. It should be a well-defined, secure cert. TLS enablement, all communication over TLS. Disable any and every anonymous login. An important one, there should be an audit trail for any CRUD operation. If you're starting it up, it's important to do it definitely for create, update, and delete operations. So you have the trail. Disable any and every insecure ports. Authentication, authorization, admission controller. Image admission controller, make sure that images coming in your cloud is trustworthy. The stuff we talked about earlier, where you need the kind of vulnerability advisor or mutation advisor know that if there are any vulnerabilities in your images or when your images are running as container, there are any mutations happening. Pod security policy. It really defines how your pods are running. So you can make your pods run as restrictive as you can, or allow it to run, get any privileges, and do in between. So it's really good to define pod security policy and make sure your pod adheres to certain pod security policies and know that which ones are running privileged, under privileged conditions. Touched on that one. We talked about quotas. We talked about PSPs. And there are so many other advantages to run your cluster such that it's grouped into namespaces. It really gives you a very clean way of managing your cluster. The other things to keep in mind is the resources created in one namespace is always hidden from the other namespaces. You can set up RBAC policies so that your users are divided into teams, and some teams have access to only certain namespaces. So that's some kind of a summary chart. And the point to emphasize here is that production thinking doesn't end anywhere or doesn't start at any place. It starts and ends from end to end. When you start building your containers or building your images, when you're ready to ship it, when you're ready to deploy it, when you run it, taking advantage of the features that containers provide you and Kubernetes provide you, it's really worthwhile to keep these things in mind from end to end to get the production grade setup in terms of Kubernetes, the cloud provider, and in terms of how you write your images to run. It's not one person's job. It's from end to end. Let me quickly touch on IBM Cloud Private. All the points that I touched on are covered with the cloud provider or the cloud that we are building, Cloud Private. And it's based on open source Kubernetes and Docker. We add core operational services on top, log management, which is open source Elk, monitoring, Prometheus, Grafana based. There's metering. Metering tells you exactly how people are using the cloud. Security is enabled end-to-end. I touched on a slide where I called out certs, enabling TLS, RBAC. That's all covered through the model that we provide in the Cloud Private. Alerting, Prometheus-based alerts. Deployment, we use Helm for our deployment. We actually have added features in the deployment to make sure that we have security from end to end. So we have implemented impersonation in the tiller to make sure that whoever starts the deployment is the one who is deploying the charts. And then the content catalog. We have a catalog of all the open source. That we support, plus you could add any other Helm repo to the environment, and then all the IBM supported middleware. I want to make sure we have time for the demo. This is kind of repetition of the chart. And that's the digital asset. I've uploaded the slides. We do have a community edition version of IBM Cloud Private built on Kubernetes and Docker containers. That's on the Docker Hub. That's easy to download and use and free. And there are other garage methods and other digital technical engagements that you can use. All right, so let's get to the demo. By the way, we tried a lot to make sure that our demo runs, but the issue we ran into was we figured out yesterday we better create a movie because we really cannot survive with the online demo of a live demo. So that's why it's a movie. And the demo is all based on ICP or IBM Cloud Private.
Okay, so we're going to start with looking at the different pod security policies that we have in place inside of the actual namespace. Basically, we created an app, a production level app that is supposed to kind of demonstrate, how we're supposed to go through the flow of, creating your production level app. So what we did was we created a new namespace, and we have a specific pod security policy here. By default, we would use the restricted pod security policy so that we wouldn't give that much privileges to any type of apps that are running in that namespace. But in this specific namespace, we're actually using the any UID host path namespace, because in a second, when I go to the deployments that are actually in that namespace, you'll see that we're using Mongo as a microservice, and Mongo has to have some type of host path in order to access the data that it's storing in a mounted volume. So now what we're doing basically is going to navigate you to the workloads and then go to the deployments so you can see what we actually have running inside of that specific namespace. So once this comes up, we're basically just going to filter it down so you can actually see that kube demo namespace with the two specified pod security policies. Currently, what you have is we just have the Mongo deployment that is actually deployed there, and we use the Helm chart to deploy that and set it up, and it's tied to like a persistent volume. And then after that, basically what we're going to go through is doing the actual install of the application that we have that's going to be communicating with Mongo. So you'll see that we have two different microservices that are going to be communicating with each other for this demo. So now we have the Helm chart deployed, and it has a few resources that are attached to it, but right now we're just looking at the deployments. And you'll see that there's currently a couple of one pod available, even though we specified that we wanted 3 replica sets. So inside of here you can see once all the pods are actually ready, you can drill down a little bit further to see that whether or not, it really is healthy. So on this page, you would actually see if it's not healthy, you would see something like this. So let me bring up this slide real quick. So here's a screenshot that I have. Basically, in this screenshot, you'll see that my pod didn't come up because the readiness probe basically said that it wasn't ready. And so basically it killed it because something happened and we didn't configure it properly. But because we added that, we at least knew, okay, something's not right. So we need to go back and look at it, right? So going back to the demo. And again, this is where you would see, everything is ready and your pods are healthy due to the liveliness, the readiness probe being okay and the liveliness probe being okay. And then that's the container, that actually has the app code on it. And so from here, let's see what we're going to be looking at. So we have, So let's just we're going to be looking at the Docker file, because we actually talked about how you shouldn't store, privileged information inside of your Docker file. So this is just an example Docker file that we will use, typically because we are deploying our app in multiple, for multiple operating systems, we would have either a Docker file that is updated to use, the different type of operating systems, like some type of RHEL Docker file, some type of Power-based Docker file, but we would ship all of our applications on top of, different platforms. But in here, it's a single node process. You'll see that we're only running this as the nobody user for this specific, version, this specific Docker file. So if somebody, actually exec'd into the pod or SSH'd into the pod, then basically they wouldn't have root access. They would only have the nobody access, which means they can't really edit anything. They can't do anything. So let's go ahead and keep going on from there. And we're only exposing the ports that we need to. I mean, that's pretty common knowledge. So from here, we did kind of touch on making sure that you don't store sensitive data inside of basically in plain text. So, we use a username and password in something. And so instead of actually putting it inside of the charts, what we're doing is creating a secret, which basically means that it's encoded. And we're pulling that data in as a environment variable to get that data so you don't really see it, right? So we're storing all of our secure data in a secret. And let's see here. And from here, basically, you can see that you can scale this deployment up, or you can scale it down, and you'll see right here that the number of pods is about to go up, even though right now it's only 3. And then we come back in here and you'll see, we got more pods, right? And then basically this is just showing you that, we have different users that have different levels and authorization and authentication. But that was just another thing that we kind of touched on inside of the talk. And I think that's it for the demo. Do we want to pause for questions now?
Any questions? Yep.
If what is deleted? If a namespace is deleted, how you would do the backups, right?
Well, hopefully your production namespace won't get deleted. But that's why we do recommend have the cluster failover as well. So that, if there are accidental stuff as deleting the namespace, then you have a cluster failover. You do set up a cluster failover in case of your production environment. Yep. But to think about it, when you're creating the namespace and you're deploying containers in it, you're not storing any persistent data inside it. That's a goodness, because all your data should be really outside in a different database. So your data should never go down if you should not lose your data if somebody kills the namespace. Yes, if it has to be a production one, then you do set up another namespace. You know what's running in there, you do that. But ideally, you should have a cluster failover. I can't hear you. 1 second.
Now, one way to handle that, though, would be to actually have the shared PVs.
Yeah.
So if one of them actually got deleted, then, because it replicated over to a different one, right, you would actually have all that data replicated to the other shared persistent storages. And that's why on one of the slides that she presented, either you're going to use a database, hopefully, and you have, some type of HA or replication in those databases set up, or you use a shared persistent storage. And if you have multiple replicas of that, which is a best practice, right? If one of them ends up going away, then you still have it on the other two. Mm-hmm.
Thanks. Yep.
So, So in a large organization, in order to produce a production-ready application, and as you said, it will go to a long pipeline, and there will be a lot of people, roles, and parties involved. For example, like a developer may be focused on just business logic, and they may not know about security, about how to update applications, security, and optimization of resources, etc. And they may not even know containers or Kubernetes at all. So I think if the pipeline is not working organically, then this process may be very inefficient. So I wonder how a large organization can solve this problem. For example, how IBM have been dealing with this.
I'd say that's a good question. And I'll give you an example. We do create images, and we had all the squads run the vulnerability advisor on their own, or pen test, or zap test on their own per squad. But what we are doing right now is, and it's a cultural change, it's not something that happens over time. What we are doing is integrating all the tests, automating it in the pipeline itself. So when you are pushing the image, there is the vulnerability advisor getting run on your images. There is the pen test, there's other tests that gets done. So it's as much automation as possible is really good. CICD squad, we have a separate CICD squad that actually works on this specific problem day and night, so that other squads don't have to worry about it too much. They get the issue to resolve when there's a vulnerability found in their images, but they're not the people to worry about, oh, what all tests do I have to run on my images or in the environment. So this is something CICD squad that thinks about it and gets it integrated in the pipeline itself. So that's how we are doing in IBM to make sure that we don't miss on these. We don't put the burden on each of the squad. We don't have to we definitely have to educate all the squads, but we don't have to put the burden of doing all the tests and making sure nothing gets left out. It's automated in the pipeline itself as much as possible. I agree, not everything can be done though.
And
Want to add, Erica?
Nope, I think that's pretty much it. But yeah, once they actually automated that process, it made our lives a lot bit easier. Yep. Because otherwise we have to do it all manually. That's it. We ain't got no time. Yep.
Any other? Yep.
So in the CI/CD pipeline, so is it that you need to, for example, push the image to the test developer environment first, and then when you pass the test, then you promote it to the integration test, something like that, step by step?
Yeah, we actually do have we have basically a very detailed CI/CD process. So basically, we go to our integration phase, and then we do some testing on the integration in all of the integration images before we actually do the promotion. And then from there are just different, deeper tests that we do on those level of images once they actually pass before we actually do the promotion for each stage. So. And then once we get to a certain stage in our release cycle, then we actually have a point where instead of actually automatically doing, like the promotion, we start cherry picking images so that we don't let any other changes come in that don't need to be added.
So they are all happen in the same cluster using the different namespace, or they are in the different cluster?
Different clusters. Yeah.
Different.
You could do it.
Yeah.
You could do it by namespace as well. As you know, namespace helps you create virtual cluster within the cluster. So you could do it. That really depends on the size of the organization. Mm-hmm. But Erica touched on it. Automation is the friend. We go through whenever we create new features. the first thing is the test automation should be done, and that it gets integrated in the pipeline. So, when you're running your, when you're adding more OSs, or when you are doing other feature development, you can do the regression tests easily. So that is really your friend for production environments.
About your CICD pipeline, do you do some manual tasks in the pipeline? Maybe some manual test?
We do some automated tests in the pipeline, but there's also manual tests for the deeper level testing that we do before we actually promote it to like a release level or a stable level. So we do both. We do automated and we do manual before we do the promotion of those specific images between the stages of our pipeline.
Right. Yep. And we have linting done as well, so that really helps it clean. Yep.
And I think that's it for this session.
Yeah.
But thank you all for coming out. That's a process.
There's a process. There is a separation of duty involved there as well. So the debugging process, the way it happens is we have the ELK environment set up, so we have the logs. We have audit trail set up, so we know, who caused it. So in terms of if it's really the auditing problem, we have audit trail set up. It goes to the SIM database as well, like a QRadar, so you can find out exactly who did it, how did it, date and time tracked. We have monitoring set up, Prometheus and Grafana, so you can see the events coming in, and there's out-of-box alerts set up as well, so you can get alerted if that's caught. And then for logging side, once you figure out when the event happened, you can go to the logging, which is ELK and Kibana based with the Logstash to buffer the data and send the data over to Elasticsearch. So you can look at the logs. We do collect standard out, standard error for all the containers. Since it's a cloud, you can bring your own images. You can set up FileBeat as sidecar to send your own data over to the Elastic. So it is all about setting it up right and then be able to see the logs. So yes, we do have access to the logs to see what's going wrong with it. Yep. All right, I get the indication that we're done. Thank you, everybody.